Good morning, GMGM. Thank you, everybody here, for choosing to spend your time at our third inaugural NoirCon.
Hi, everyone. In this workshop, we are going to be building a really simple private smart contract on Aztec. First thing, who has been to the previous workshops, explaining what's theoretical stuff about Aztec? Who knows about private versus public space? Who has set up Aztec once on their computer? Oh, shit. OK, so on that QR code, there are some small instructions into setting everything up. You will need to set up Docker and install Aztec and download a repo. If you want to follow along in the workshop, you can do that. If you don't want to follow along and just want to see me code, that's fine too. So yeah, my name is Shaito. I'm from Wonderland. I'm partner lead with our partnership with Aztec. We are building a couple of things. We are building a lot of developer tooling with, for example, the Aztec boilerplate that allows you to start projects really easily, or the Aztec benchmark, which allows you to benchmark two different versions of a contract and see how much DA cost or L2 gas you are using compared to that. And then we are also building the standards. We have a repository that is called Aztec Standards that has a token, an NFT, and other standards that we will start building over time. OK, I'll take out the QR code. So if you want to scan, it's now. So if you follow along, you should have. Wait, I need to remove. There we go. You should have something like this. And if you run yarn, and then yarn compile, and run yarn test, it'll run the tests. I'll show you the contract in a minute. Zoom, yes. There. Good? The internet does not help. OK, in the meantime, while this compiles, we are going to be using the counter contract. It's a really small contract that basically has a public variable that is called a counter, which is a public mutable. And it allows anyone to call a private function that is called increment. And the increment function, what it does is that it calls itself, calling the function increment internal. And it enqueues it to public. That I will explain in a minute. When that call happens, it calls this function, the increment internal, which reads the counter and then increases its value by 1. That's literally the contract. That's it. The interesting part about this is the mix between private and public space. Because you are calling a private function, you cannot access public variables. In this case, you have the counter, which is just a number that is public. And you wouldn't be able to access that from private state. And the only way for everyone to know what the value of counter is if it was public. So what you do is ignore that. Come on. There we go. So what you do is you use this keyword or this call, which is enqueue. And what this basically does is that this will execute. This will start the execution pipeline for your function in private. It will do everything, and then it will call the public state in the end to execute that. So this is a way for you to interact between private and public. You can interact from private to private, from private to public, but you can never interact from public to private. Because private execution always happens in the user device. So if you wanted to do public to private, and public execution happens on an RPC, you wouldn't be able to execute anything on private space. So those are the interactions that are valid. First thing, let's say that I don't want everyone to be able to execute the increment. So what I will do for that is, let's say that I only want the other variable that we have, which is admin, to be able to call that function. That is really easy. What you basically do is you can grab the sender. Well, it literally is completing my code, but you can check that the sender is equal to the value that we have in storage, which is owner, sorry. And then you can revert in case it's not equal, not owner. OK, so this call here basically like grabs the sender of the function, of the transaction, sorry, and then it compares it to the owner of the contract. Just adding this will guarantee everyone that the private call that is being executed is being done by the admin. No one else will be able to call this. And just as an example, if we go to, let's go to increment.nr. This is a test. And then let's say that we want to set up another account, which is not the admin. Yeah, let's create another account, and let's call it not admin. And if we execute the call from not admin, now we shouldn't be able to compile and test. This should revert just because we don't really have, we are not really calling from the admin. It's actually, oh, it's admin, sorry. Confused the name. Takes a little bit of time, but yeah, it's compiling everything. And now one test fails because we are calling it from another user, basically. Let's add a little bit more functionality. Let's say that the owner doesn't really want to be present all of the time to call increment. Like, let's say that you need to call increment like multiple times a day, and it's a hassle for the owner of the contract to be there all of the time. And he basically wants to set up multiple people that are able to call this function. One way to do this would be introducing nodes. And a node, explained in the previous workshops, is basically a small unit of information. It's basically abstract, literally, that contains a little bit of information. For that, let's create the folder types, and let's call it incrementor node. Let's think that we will, I'll copy this just so we don't take that much time. Cool. And now we have set up our first node. This is the incrementor node. It only has two really, really small pieces of data. It has the owner, which is the owner of the node, who will be the one that will be able to call increment, and it has some randomness. Why the randomness? Because if you only have the owner in a node, it would be really, really easy to brute force checking different addresses to see if they are incrementors. If you use this randomness, it will be literally impossible for you, or really, really difficult, let's say, to try to brute force and see if his address is in the incrementor nodes. A couple of things that we implement here. Let me remove that. We use the trait equals, which basically allows you to equate a node to another. And then we set up this, which is a way that you can give some functionality to your nodes. In here, we are able to add any functionality that we want. And the only functionality that we added now is a function that is called new, that receives an owner, and it creates the randomness inside and returns the node. This is just for us to be really simple to initialize nodes. We don't even need to generate the randomness in the contract. And just a quick thing to explain here: the randomness is generated inside an unsafe keyword. That is because randomness is generated with a call to an oracle that is executed in the user Pixie. The interesting part about this is that because this runs in my computer, I am able to change these things. So there is no way for you to be 100% certain that I'm using a random variable. I could run this 7 trillion times, even using the same way of generating randomness, and run it 1,000,000 times until I get a number that I actually like. So that's why we call it unsafe. In this case, because the one that will be generated, the incrementor nodes, is the owner of the contract, he has no gain into using a randomness that is not correct. There is no way, he doesn't win anything by doing that. Cool. Let me to use this incrementor node. Cool. This is just importing everything. And then on main, we will remove this. Cool. And there are multiple ways to use nodes. In this case, we will use a data structure that is just, it's a private set. So we will call it incrementors. I'll call it private set, incrementor node. Cool. Now we have set up our first private set. One thing that I forgot to mention is that I mentioned before that private and public state is like completely separate. But one thing that I did not mention, which is interesting, is that in here, this is a private function, and we are reading the variable admin, well, not the variable, but the parameter admin. And admin is public. Aztec does some magic things here, and it allows you to use public immutable variables, public immutable values in private, just because they are initialized at the start with the contract. This like gets indexed or whatever, and it allows you to access them in private. But everything that is mutable, you won't be able to access. Like if I try to call the counter, it will say that it does not exist in my storage, just because it's mutable, and there is no way for you to prove that this is the latest value of counter in your computer. Cool. Now that we implemented the incrementors nodes, we'll add a new function for the admin. Let's call it, let's say it's external. Let's call it, let's say it's private. And let's call it, okay, add incrementor. Let's do that. Okay. Let's grab the sender of the transaction, and let's check if the sender of the transaction is the owner, because we only want the owner to call this function. So this grabs the sender, it compares it to the admin that is in the contract, and if not, it throws not owner. That's it. And then what we can do is insert a node. Let me create it separately, actually. I think it will be easier to kind of follow. I should disable autocomplete, actually. Cool. In here, we initialize our node, and we use the function, like this helper function that we created that is new. So that's why it only needs the incrementer as a parameter. It doesn't need the randomness, because it generates it inside. And then afterwards, we can insert it into the private set. Cool. Now our node is in our private set. The interesting part about that is that inserting a node into a private set doesn't really help us in any way, because no one has access to this node. No one has it. For a node to actually make sense, you need to either share it off-chain, as it was explained before in other workshops, or you can share it on-chain. And this is via the emit function. So every time you insert a node, it returns a node emission. And here, there we go. And then afterwards, you can decide who will get this node, who will be able to read it. And to emit that node, you basically call node emission dot emit. And in here, we send first, the first parameter will be the address. In this case, we want the incrementor to get this node. And the second parameter is really interesting. It's the type of message delivery. Okay? The type of message delivery can be unconstrained or constrained. The difference between these is that if you emit a node in an unconstrained, in a constrained way, sorry, there are more checks into validating that whatever you are doing is correctly being done. So, for example, in this case, we can call it constrained on chain, or we could call it unconstrained. In this case, we'll call it constrained just because of like simplicity, and it's the safest way. But we should be able to use it unconstrained here. Why? Because again, because only the admin can call this function. He has absolutely no gain into emitting this node in an incorrect way. Like if I encrypt it in a different way that you know how to decrypt, you just won't be able to access the node. And why am I doing this if I'm not actually giving you the right to increment? So I could do it unconstrained, but anything that can be done by users and could kind of fuck up someone else if they did it in a bad way, you have to do constraint 100%. Let's say that in the token contract, in the transfer, I allow for the creation of nodes, of balance nodes, without them being constrained. I can send you a node that is encrypted in a way that you don't know how to decrypt, and there is no checks on chain to actually validate that the message delivery is being correct, and you wouldn't be able to access the funds. So in that sense, like I would be able to pay you, you would be able to see that there is like something that you received or that I sent something, but you wouldn't be able to decrypt the node. Again, in this case, we'll only use constraint just because of simplicity, but basically when you are building something, you will need 100% to think about the different types of delivery. Yes?
So this is putting the note on chain encrypted.
Yeah.
This is not the commitment. That's separate.
Yeah.
The commitment is separate, and that will always go on. Okay,
yes.
Got it.
Correct.
Thank you.
Like the commitment always happens. The commitment always happens, but then like you can decide if the node gets shared on chain and then published to one, of course encrypted, like there is no way for anyone else to read it. But the commitment always needs to be like shared on chain, because if not, like you would be able to duplicate nodes. Yep.
Thanks.
Cool. Now we finished with the unincremental node. Do you want to send it in the HackMD? So if anyone is like still following, in the HackMD we will be sharing when we complete a function. You can just copy it and paste it. We also have a branch that is called fit/solution. So if you want to see it after the talk, you are also welcome to do that. Okay, so in this case, now we added an incrementer, and the owner of the contract is able to call this and create a node that basically gives the right to someone else to call increment. Now we need to actually implement that logic, the logic that only allows the incrementors to call this function. For that, we'll need to remove this assert. Let's create a new function that is called a new variable that is called isAdmin. And for this, you will check that sender is equal. Now let's call it, actually, let me call it admin. Equals to storage, that owner, that read. Cool. In here, we read the owner. And then if the admin is different than the sender, so only in the case that basically the admin is not calling this function, we'll do this check. And in this check, what we will do is let me copy it actually. It'll be easier. Cool. So because a private set like is basically an array in some sense, we need to filter those nodes. And we need to check if the person that is calling this function has in their own private state, they have the node and they are able to decrypt it. They can prove that they can decrypt it. In this case, what we'll use is these node getter options that allows you to select like different filters to find the nodes that you actually need. In this case, the only thing that we need to check is that the owner, which is a property of the incrementer node, equals the sender of the function. That's it. And then we set the limit to 1, so that because we know that it will always return at most one node. Afterwards, we can call storage.incrementors.get nodes, and we send these options so that it returns the array of nodes, the final array of nodes. And in this case, if the person that is calling this has one, or let's say, or more than 0 nodes, we know that they are an incrementer. So we only need to add an assert and check that the nodes array is greater than 0. That's it. And if it's not greater than 0, let's say not incrementer or admin. Let's remove this time. Cool. So now we added that. Now the function increment can only be called by either the owner of the contract, which is the admin, or someone that has received an an incrementor node, basically. And then let's add one last piece of functionality, and then we will go over to some tests and see if we can deploy into DevNet and deploy into the local sandbox. We'll add another function. And let's call it remove incrementor. This basically will allow the owner of the contract to remove any incrementor node. OK, so to explain something that I added before, in here we added 2 node emissions. This second one wouldn't be necessary if we weren't going to do this step. Like if we only wanted the incrementer to access that node, that's fine. We can only emit it to the incrementer. But because in the future we want to allow the admin to be able to nullify that node, we also need to share that node with the admin. If not, the admin wouldn't be able to call or to nullify that node ever again, because they will lose that information, unless they keep it off chain and they add it later. But this is like the simplest way. So that's why we added the second emit there. Cool. And let's actually copy it from here. Cool. And the remove incrementor, sorry, will basically do the same. It'll check that the caller is the admin of the contract, and then it will remove the node from there. And the removal of the node is really similar to getting the node. It's just using another function. That's why I will just copy it. And we will do the same filtering, basically checking that the owner does not equal the sender, but it equals the incrementer. So what this will do is that when the admin of the contract calls this function, it will see the incrementer private set. It will have all of the nodes that the owner has created ever, and it will find one node, at least, that has the incrementer that they want to remove as the owner of that node. And then afterwards, because you have the preimage of the node, and we allow the admin to call this, you will be able to call, instead of get nodes, which literally like returns the node, you can call pop nodes. And the difference between get nodes and pop nodes is that get nodes returns you the node, and that's it. And pop nodes, it takes the node out of the set. How? It basically nullifies the node. So now that node is not usable anymore. Yep.
You would have to do this for every node. So hypothetically, if you did it twice for one user, you have to nullify both.
That's a fantastic question. Yeah. Yeah. Like if you did it twice for one user, because let's say that you made a mistake, you would need to do this like multiple times. One thing that we could do is like we could remove this set limit to 1, and you would be able to pop multiple nodes at the same time. Ideally, and we didn't do this just because it was like really short workshop, but you should be able to find a way to kind of stop the owner from creating multiple nodes to the same person in the add incrementer. At the start, when we were planning this workshop, we ended up like trying that out, but it didn't make a lot of sense. I'll explain why. Basically, what we did is we used this to kind of find the node. If there were more than 0 nodes, we reverted. That works, right? Like it basically like checks if there is a node, and if not, it will revert. So if the admin doesn't have any malicious intent, let's say, which of course makes sense that the admin won't have any malicious intent, that would work. But because getting nodes depends on the cooperation of the Pixie, if the admin had something to earn by not providing the node, they could do it. Like basically, this doesn't force you to present all of the nodes that actually kind of match this criteria. So you could have the node, and you could be like, no, I don't have that, because it depends on your private storage. So for this, you would maybe have to do something like more magical related to nullifiers and something like that. And nullifiers you cannot kind of skip, because those are always posted on chain in the nullifier tree. So let's say that every time, and I'm just getting this out of my head, every time you add someone as an incrementer, you publish a nullifier, And then if you go to add the same incrementer a second time, it will try to publish that nullifier, and the nullifier will already be there, so the transaction will revert. The problem with doing it this naive way is that if you do it this way, I add you, I then remove you, I post the nullifier, and let's say that a week after that, I want to add you again, then I'm fucked. So yeah, I won't be able to add you anymore. So you would need to like find another magical way using nonces, or I think at some point we kind of played with that, but it's complex if you want to do it that way. Yeah. But yeah, you could like just, the admin doesn't have any malicious intent. You could add this and revert in case there are more than 0 nodes, just to avoid the admin from making mistakes. But that's it. Yep. Okay, cool. Now in the remove incrementer, we check that the sender is the admin. We try to find the node, and if it finds more than 0, it pops the node. In case there are 0 nodes, like there won't be any issue. So that's fine. Cool. And now let's go see if we can write some tests for this. That's fine. It's actually called, yeah, increment.nr. Okay. Cool. There are a couple of tests that we could write for this. First, let me remove this test. Actually, let me copy it and have a second one that actually does what it needs to do. Because now we have a failing test. Let's say that we call these tests reverts if caller is not admin. And to be able to revert, what you basically do is really easy. In the test, you call should fail with, and you add the error there. In this case, because it's increment, it should be, let me check. Yeah, not incrementer or admin. Cool. And now if we run the tests, and I think my issue is that I keep calling owner when it has to be admin. Okay, this is actually my mistake. Cool, I fucked up with the variable, that's it. There we go, and let me write it here, and let's try again. I haven't compiled while we have been coding, so yeah. No, it's still... I hope it works now. Cool. We forgot the previous test, and it had the admin there. So yeah, that's it. Or that should be it. So now we should have, I think, 3 tests, and the 3 should be good. 1 is failing, and it's expected. So it should be marked as green. Cool. Now we have 3 tests. Awesome. Let's see what else we could write. Let's try to write a test where the admin sets up an incrementer. It's called unconstrained function incrementer can increment. So we will set up an incrementer, and then the incrementer will call increment. Let me copy the setup here just for simplicity. Actually, let me copy it fully. Cool. We'll create a second light account that is called incrementer. And we'll check that if increment is called by the incrementer, this should revert. while that is happening, we'll called by the admin, and the admin will call the function to add an incrementer. It reverted, cool. And then add incrementer, and we add the incrementer. Cool. And now if we run it, cool, for test pass. What this is basically doing is creating the contract, initializing it, and then the admin is adding an incrementer, and the incrementer is calling increment. And now we can see that the counter value is 1 instead of 0. Like we could, just to like be completely safe, in our test we could check that our counter is 0 before, so that we know. Actually, let me do it here. Yeah, there we go. So that should pass too. And I forgot to read it, sorry. Let's call the counter a mutable variable, and let's assign it again here. Hmm? That's fine. Yeah, should be pretty quick. Cool. Now for test pass, let's also write another test. Let me see which other test we can check. Add incrementor, remove incrementor. Let's try with a test constraint where another reverts if not owner calls remove incrementor. That's a really long name. Let's add this one, and then we'll go ahead and run our sandbox and deploy everything into our sandbox and deploy everything into devnet too. By the way, this is, if I'm not mistaken, this is all running on devnet 0.5. It should be compatible with everything that is related to devnet, but remember that if you use I'm pretty sure that the default instructions in the Aztec website don't tell you to actually use devnet. They only use like the installer from Aztec, so it will install the testnet version. So you need to be like really explicit there. And when you do Aztec app, you need to send the version, like basically 3.0.0 devnet 0.5. So yeah, just a small reminder there. Cool. For this function, let's call it not owner. And the not owner is going to be calling remove incrementor. And this should revert. Sorry, should fail with. There we go. And it's not owner. Okay, there are multiple tests that we can like still write about this, but I think like basically this is like enough. Yep.
So I'm trying to wrap my head around what's public and what's private. If we remove the getter, the get counter getter, would that become private?
Oh no. It's just a matter. Let me show you. It's just a matter of the type of variable that you use. Like if you check here, you have the counter that is a public mutable. Okay. And then in here, the incrementors are private set. So it's the type of data that divides like public and private space.
So if we made counter a private mutable, then could we still access it with the public
That's
getter?
a good question. Okay, so in that case, what you would do is, let's say that only the people in this room know about this contract, okay? And then what we do is we create a node that is called counter node that tracks this number. The bad thing about that is that I would need to share this node with everyone here so that you would be able to access it. If you want to do this with people that are like completely outside this room, they would need to like contact me, or I should like build a website that kind of shares the pre-image of the node or whatever for you to actually find it. And it will be really difficult because nodes are append only, let's say. They are not like mutable itself. So if we create one node and I share with everyone here, and then you call increment, and you increment that node, you are nullifying the previous node. So you would need to share the new node with everyone here, like one after the other. That would be like insanely costly in terms of storage. Yeah.
Okay, thanks.
So yeah, that's a really good question. Like basically, the thing that Aztec has is that contract design works really, really differently than doing it in Solidity. And you have to, like, it took us quite some time, like quite a couple of weeks to actually like wrap our hands around it, because it's completely different, a completely different like programming paradigm. Because it's not like at first, like you basically go into Aztec, and the first thing that you like kind of think is that I can create a private node and everyone can just like, I don't know, like access and increment that value, and no one knows the value, and that can't happen. Like, because things are executed in my computer needs to know like all of the values. So I cannot have something that no one knows, but I use. So for example, if you were doing a contract that is like much more complex than this, let's say that you are doing Uniswap V2 or something like that. So like a DEX, like the simplest DEX that you can imagine. A DEX is basically like a pool that holds two different tokens, and the ratio between token A and token B determines the price. So the interesting part about this is that if you want to build a DEX on Aztec, at least you will need to have the balances be public. Because if not, how can you, like how would you know how much you will get by executing the transaction? So every time you are developing an app for Aztec, you need to think, like you basically start thinking, okay, let's start with everything private, all of the variables, everything. And then things start coming to your head and you're like, okay, if I do this private, how the fuck will this person access like this piece of data? Like they literally need to execute this in their computer and they need to do like math equations, and you need to know the values of everything. If not, like you cannot do it. So yeah, at least like how I interpret it is that we start with everything private, and then slowly we start only putting public the things that 100% need to be public. Like there is no other way to execute it. And usually things that need to be public, I understand them as things that anyone should be able to read. Like, because you could think about it and be like, oh, let's put it in private, but if someone wants it, we share it. And it's like, that's public. Like, just do it publicly, and that's it. That will be like much more simpler for users. Because, yeah, you could make it so that everything is private, and then you go inside the website, and the website shares stuff with you. But what are you like winning by that, you know? So yeah, private and public like execution and interactions are like massive there. It's really important. And yeah, and you can see it here. Like basically, the counter is public. And the good thing about that is that there is only one value for counter. So if we were sharing a node, like all of us together, let's say that we wanted to do this with the counter node that we all share between each other. And we all want to increment that counter. And he sends the transaction, and I send the transaction. One transaction will come first. And the first transaction that comes will nullify the node that was in storage, and my transaction will fail. Because that I will try to nullify a node that does not exist anymore. So yeah. Cool. And let's see Aztec. We'll start the testing environment, the sandbox. Let's wait for it to start. Cool. And in another terminal, we'll do yarn deploy counter, I think. Let's check it here. Cool. Yarn deploy counter sandbox. And then it was, wait, I forgot how it was. Deployer secret, okay. I forgot. Cool. What we will be doing now is deploying our counter into sandbox using like this secret. Please don't copy it. But yeah, you can use any secret. Of course, like if you are doing something that is more productive, you would like save it in an environment or whatever. But yeah, let's see if it works. Cool. So we have the contract address here for the counter. And then let's see if we can also find it here. I think it will be a little bit annoying with all of the, this is the fee payment contract. Yeah, here. So you can see like in our local environment, we successfully like deployed our counter. And if we had some scripts, some JS files that want to interact with this, we should be able to do like any end-to-end tests. I won't go into end-to-end tests here, but they are like pretty simple. I'll show you only the test that comes with this, which with the repo. It deploys the counter, and you just basically call counter.methods, and you have all of the methods that you can access. Yeah, you check the admin, check that it's equal, get the counter, check that it's 0 when you start, and then you call increment from the owner, and afterwards it should be 1. It's really simple. And lastly, let's see if this works. Let me stop the sandbox. Cool. And let me just run the same as before. What's happening? There we go. But let's call the other one and deploy to devnet. My computer going insane. Cool. Devnet. Cool. And this is not working. Basically, this will use the same thing that Josh showed before. I think I have no internet, actually. This is using the same thing that Josh showed before, which is basically the sponsor of the FPC. Fee juice or gas is a really interesting thing in Aztec, and it's still not completely polished, let's say. But for now, for devnet, for every like developer use case, you have what they call a sponsor FPC, which basically like receives any transaction, and anything that comes in, they just pay for the transaction. That's it. In the future, the idea would be that you will be able to pay for fees in any token, and there will be like different FPCs. Basically, like let's say that someone runs an FPC that accepts USDC as payment or whatever, and this is really interesting. Cool. We send the transaction, and let's see if it actually deploys. Yeah, you can see that here it's registering the contract for the sponsored FPC and the account that we are deploying with here. How long does a transaction take in Aztec?
30 seconds.
30 seconds. Let's see if it's accurate.
It depends.
It depends on the state of the network. Cool. Now it deployed, and you can access, let's see what I can do with that. Why is it so grainy? And we go into Aztec scan. There is like, just for you to know, Aztec-scan has its devnet.aztecscan.xyz instance that allows you to see everything that is happening on devnet. And yep, here's the call. There's not much to see as deployments are private. So yeah, in the future, the idea would be that you would be able to use the contract type, which is the class ID. Like this is published. And if you have a mapping from this class ID to the code of the contract, you are able to publish this and to show this. But if you don't publish the code, there is no way for you to see it, actually. So yeah, that is basically it. Anyone has any specific questions or whatever that you would like to discuss? We have 10 more minutes, 14 more minutes. Cool. Yeah. I mean, if you mean like, for example, the variables that we are publishing or a bytecode? If you don't have the code for the contract, no. Like that's, you won't see it. Like same as Solidity, right? Like you would need to basically like decode stuff and kind of.
I know. I mean, let's imagine that I have the code for the contract. When I check it, I will check the public variables, but I could not get the private. Is that right?
Yeah, correct. Like you will see like garbage there. Yeah.
Okay. Okay. Awesome.
Yeah. Oh, you would only be able to access like the public state there. So yeah. Yeah.
Is there a concept of like verifying the contract there?
Verifying the contract like on the scan?
On the Explorer.
Oh, yeah. So like right now, I think it's not something that is like completely public or easy to do, but the guys at Aztec Scan are working on that. Like they have this part here that's called standard contract type, and some of the contracts are registered. Like for example, we have our own token standard, and if you deploy that, it'll show you like the data for the token standard and a link to our repository, but they just need to expand that registry. But yeah, in the future, you will be able to verify your contracts in the scans. For sure. Yep.
Are there some functions for decrypting private data, like your own note? Someone sends you a note, can you decrypt it and see what it actually is? Off-chain?
Yeah, of course. Like there are basically like two ways to find your notes. The most naive way would be basically like to brute force. Like you can literally go and try to brute force decrypt every node in existence for Aztec. I mean, if you don't know and you want to check if someone sent you a specific node, you would need to register the contract. Oh, actually, like, let me give you a little bit more context. Nodes are siloed into each contract. Like there is no like just a nodes registry that is there and all of the nodes are like swimming around. Each node is like tied to a particular contract, so you register that contract and then you read the nodes for that contract. Oh, the Pixie grabs it and decrypts it immediately. Like they know how to do it. Like, yeah. In the case, for example, let's say that I do a token transfer. And again, like I'm repeating things from the previous workshop, but I'll repeat it anyways. I think it's fun. There are multiple ways for you to know that I send you money. One would be for me to share everything off chain. Like basically, I send you the money, I publish the nullifier for my nodes, and then I show you a QR code that you can scan, and it adds them to your Pixie. This is like locally shared, like everything off chain, whatever. Then you can try to brute force, like you basically add the contract, try to brute force any node in existence for that particular contract, and if you like get a hit, fantastic, you know the node. And the third one is node discovery. Basically, Aztec noticed that it's literally or kind of impossible for people to really try to decrypt all of the nodes in the system. That would be insane and it would take a lot of time. I don't know if it happened to you. For example, if you use Monero or Zcash and you try to start your account from like block 0, it would take like hours for you to actually like sync the whole chain. So they came up with a like scheme that is really interesting that is called node sharing or node tagging. And what that basically does is that it indexes the node based on the sender and the receiver address in a way that the RPC cannot actually know that value. So if we know each other, we can privately, like off-chain, share that I sent you money. Like let's say you send me money, I add you as a sender on my wallet, and it will pick up all of the transactions that are indexed for our pair, that is you as a sender and me as a receiver. And that will be like really quick.
Wouldn't they have to have the contract to be able to understand the structure?
Oh yeah, they add the contract for sure. Yeah, they add basically they add the artifact for the contract, and they have to register in their Pixie. Yep, for sure. Cool. Anyone else? Awesome. Thank you, everyone. If you want, we'll be around. If you see anyone with a T-shirt, feel free to talk to us. Cool. Thank you.